you please, any one of you please contact if you're able to hear me, like the chat. If you're able to hear me, please kindly confirm in the chat. We'll wait for a few more minutes until I'm going to be done and we can start. Let me know if you're able to see my screen also. Please confirm that. Hello, is it PM? Hello, is my audio clear? So we'll wait for a few more minutes until more people join. Until then, we'll discuss last week. Last week we couldn't have the lecture due to my health. So we will continue on week 3 from last time and also some aspects of week 4. And next week we will be having 2 sessions, one on Saturday next week and also on Sunday. So week 4 will cover some parts today and remaining parts from Saturday next week. And then week 5 will be as usual on Sunday. So just waiting for a few more people, more people joining. So, so Saturday and Sunday will be the same time, 3 to 5, um, and it will be the same link. So I will discuss more at the end of this meeting, sort of, like once more people are joining, so that everyone gets updated about. So, so we will discuss today some programming assignment of week 3. I think that will be our discussion, and also week 3, week 4 quiz also, the initial week 4 quiz. And I think week 3 I had 2 assignments. I think one was a programming assignment, so we'll discuss both of them sort of. The other one was on, yeah, I think only one programming assignment is there in week 3. So we'll discuss week 3 programming assignment and week 4 quiz also. First, we'll discuss about some of the concepts. I see. So there is another online for AI searching. I see. So I will discuss, maybe I will discuss with the PMRF NPTEL coordinator regarding the timings once more, so that it doesn't clash with anyone else, any other courses, and I'll provide an update via by like the NPTEL coordinator should provide you an update in the meantime. So um, right. So this is just Saturday's class is just a replacement. Will since we didn't have last week lectures.
For so much disturbance is coming, noise is coming when you are speaking.
Hello, is it better now? No.
No, sir, not much. Some background noise is coming.
Let me know if you're able to hear me now. If it's clear and better.
Yes, sir, now it is fine.
Okay. So we will discuss. I think week three's programming assignment, but also first we'll discuss about some of the concepts from week three first. Like overall, like on a very high level, what was discussed. But I think we can start with the programming assignment first, and then discuss the um, sort of the concepts also. So I think since probably you have already gone through the videos, so that's why it might be a repetition for you. We'll discuss the programming assignment from week three. Although I think and then week four, the quiz on week four, we'll discuss that. And if there are any other problems or questions, feel free to share in chat. Um, yeah. So the plan for today is we will discuss week three programming assignment, and then we'll go towards week four quiz. And if you have any other questions or any sort of doubts as such, we can discuss those today also. In terms of any concepts that needs to be cleared in terms of like Python data structures like arrays, list, and all. So we'll discuss those things. And right, so let me open my. I hope you were able to have successfully installed any software for code. Like in my instance, I'm using Visual Studio Code. I think many other people have are using many different software versions. Whatever works for you, like please type so as to get a better understanding of the course also, because without I think writing code by hand, I think it should be a bit difficult for you. So I would highly suggest
Sir,
you
your
that
voice
I
is breaking. Sorry to interrupt. Your voice is breaking
yeah,
continuously.
yeah, sure. Okay, just a moment. Hello. Is it better right now? Are you able to hear me clearly?
Yes, sir, but with a little background noise.
Okay. Yeah, I think the background noise, I think, yeah, I'll try to speak a bit higher so that I think you could be able to hear me. So I'm trying to share my VS Code. So what I was saying basically was, please use a code editor sort of to practice, because if you are not able to practice, I think the concepts wouldn't be clear later on. Discussed specifically some resources from last time. One was on HackerRank as a way to practice Python problems. So I would highly suggest you to sort of like try out those coding platforms, as well as have something like a online, as an in your local desktop or local setup, have something like VS Code or Visual Studio Code setup. So with that, we'll start with a programming assignment of week 3, and we'll write the code in the VS Code editor. So I'm sharing that also with you. Please let me know once you are able to see my screen. So just a minute. Okay, I'm sharing my screen now. Just let me know. So just let me know if you're able to see my screen. So I'm sharing my VS Code. Please put a yes and no as a comment if you're able to see my screen. Mm, Okay, thanks for the confirmation. Okay, so we will start now. So I hope you're able to see my screen now. So we'll start with the first problem of week 3. So this is NPTEL week 3 programming assignment. Um, so our first problem, if we go and see, it basically says that uh, write a function expanding L that takes as input a list of integer L and returns true if the absolute difference between each adjacent pair of the elements strictly increases. So they have given us an example. So expanding is a function that takes input as a list of numbers 1, 3, 7 to 9, and it gives me a sort of it's a boolean function because it returns me true or false. So it either gives me true or it gives me false based upon the input elements. So if the absolute difference between each adjacent pair strictly increases or not, based upon that I have to say. So for example, 1 and 3, the absolute difference is 2. 3 and 7, the absolute difference is 4. 7 and 2, the absolute difference. Remember, they have strictly specified absolute. That means even if it's negative, you take the positive. of it. So 7 minus 2 is basically the difference is 5. So initially it was 2, now it's 4, now it's 5, and 2 and 9 is 7. So basically my the absolute difference is increasing over time. So I would say, and it strictly increases. We'll discuss what that means. And if that is the case, I would say the function is expanded. So let me write this code in terms of, I mean, this is just we have to implement the function in Python itself. So let me write that. So def expanding list L. Um, so basically, if my I'll just do the following. First of all, if there are corner cases, I have to also look into. For example, if len of L is equal to 0, that means the list is empty list. I would just do return false because my list is empty. So there doesn't exist any elements in L. So I can directly say that the numbers, there are no numbers, hence there is no strict increase that we see. So that would be my return false. There is a corner case, which usually in competitive programming you have to sort of look into very carefully. Else, what I do is for I equal to I in range 1 comma len of L. Basically, that means is instead of doing, I'm starting from the zeroth index. So if I just go to the take a example problem, which is let's say 1 3 7 2 9. So basically the same problem which they have showcased here. For that, I will take index I equal to 0. That means I get the first element 1, and then I take index I equal to 1, which means I take the second element, which is 3, and I calculate the difference of these two. I get the difference, and let's say I store that difference as a variable, which is an integer variable, difference between consecutive numbers, consecutive numbers in L as a parameter, as an integer. And so this diff actually captures L of 1 minus L of 0. And remember, it says it's you have to calculate the absolute difference. So you can have some number like absolute, or it's a absolute is like a function you can use. But since this in this course we want to write every code almost by hand ourselves, so we'll probably implement the absolute function as our own implementation. So we'll do that in the course of this problem itself. We'll show how. So basically difference is L of 1 minus L of 0, and I take the absolute value of that. I stored it in diff, and what I do next is I increment I to plus 1. Basically that means my so if I just do I plus 1 equal to 1 actually, instead of doing this, I was initially equal to 0, I plus 1 is equal to 1. Now if I do I plus equal to 1, that means I'm just incrementing the index I from 0 to the second number now. So I plus 1, I would be equal to 1 now, and I plus 1 would be equal to 2. So the numbers are 7 and 2 now, and I again 7 and 3 now, and I again calculate the difference diff here, which is L of 2 minus L of 1, which is 7 minus 3, which is equal to 4. So I'm not able to see that there is something of a loop that I have to clear, so as to start from starting of the list here till the end of the list, and I have to do this sort of in a iterative fashion sort of. So what I do, I take the difference of L of I plus 1 minus L of I, or in some way I can just write it as L of I minus L of I minus 1 also, because I'm starting with range 1. That means I'm starting with I equal to 1 actually instead of I equal to 0. So I can just do L of I minus L of I minus 1. And I define a function which is called absolute. I can usually use this function ABS, which means absolute, but let's define it by scratch. Absolute function, let's say. Um, let's say absolute difference. Let's say I define the function like this. Let's define this function absolute difference. The absolute difference given a number n gives me the following. If my n is a negative number, I would return minus n. Basically, minus minus becomes positive. Else it gives me the positive sample n itself. So I can directly use this function here now, and this captures this function, this variable diff captures the absolute difference between consecutive numbers right now. And what I have to do, as per the problem, is that it should return true if the absolute difference between each adjacent pair of elements quickly increases. So let's say um, I have to show that if my at any point of time, if it doesn't strictly decrease, I can simply say it's a false thing. Otherwise, I continue till the end of the loop and say it's a true thing. So some way to I have to store some at some point whether this pattern is getting recorded somehow or not, because I'm storing diff now, but I have to know that if that actually holds true throughout the entire list. So what I do is the following. Um, I so I have a function which is, let's say I have something like previous diff, let's say, which basically means the previous element difference that I have. And let's say I have it as um, something like I can have something like, let's say, previous diff equal to, let's say, minus 1. I also define another thing like current diff is equal to minus 1. And let's say I assign current diff to the current absolute difference between and Li minus 1. So in the next loop, I goes to 2 now, and I calculate the absolute difference, and I compare if current diff is strictly, that means there is no equal to sign. So if this is the, if correct diff is strictly greater than previous diff, I just assign simply the previous diff equal to the current diff. Else, I simply just say it's false, because this thing would actually break the loop, and it will actually just tell me that function the list is not strictly increasing. The absolute difference is not strictly increasing, so I can just simply return false. But if the other case is my current diff is greater than previous diff, I'll just assign previous diff to current diff, and I'll try to continue the loop till the end. So I can have something another variable if the something like if loop ended, which is or maybe let's say something like loop index, let's say, which is this, and loop index 0 as of now. And so if this thing holds, I'll do loop index equal to the just increment loop index. So, and now what I do is at the end I add another else if condition. If my loop index is equal to my len of L. So basically, what I'm doing is I varies from 1 to L, len of L, um, and So I would just have L of I minus L of I minus 1. So how many times I'm doing this thing? So I'm doing this thing. If I go back to here, so I'm comparing these two things. I'm comparing these two things. I'm comparing these two things, and I'm comparing these two things. Basically, four comparisons I'm making, which is basically equal to n minus one in my case. N is the number of elements in the list. So I can just write it as len of L minus one. So if this is the case, I just do return two, else I don't even need to do another else condition because this is anyways done here. But I can still add return false. Now, if I give an example, let's say um, print um, expanding of the same thing, let's say 13729. And if I let's say run this, it returns me true now because obviously this thing was true. But let's say I sort of change the value slightly. You see 1 3 and then 3 1 and then 1 2 and 2 9. So 1 3 obviously has the absolute difference of 2. 3 1 again has an absolute difference of 2. So it's not a strictly increasing thing at all. So it should return me false. Uh, oops, I think there is some error in the code, I guess. Let me check once more. Um, so current diff is, let us print the current diff. I think with printing, I think this thing would be better. Okay, I see. Um, basically, this thing is not happening. Let me add current diff equal to 0. So when current diff is equal to 0, it's obviously greater than previous diff in the initial portion. And so previous diff gets uh, accumulated to current diff value for the next iteration, which is 3 1, let's say. The absolute value is again 2, and previous diff was also 2, so this thing should not hold true. So as you can see, it returns me false as per the current. So now let's go to a different example. Let's say I have 1 7. 1 7 has an absolute difference of 6. 7 2 has an absolute difference of 5, and 2 9 has an absolute difference of 7. So this is again strictly not strictly increasing. So because 1 7 is 6, but 7 2 is 5. So again, it should return me false. But let's say I just replace 2 and 7. Um, so then again, is this strictly increasing? It's again a no because 1 2 is 1, 2 7 is 5, 7 9 is 2. So last difference is 2 only. So it's not a absolute difference strictly increasing. So it returns me false. But if I change it to let's say 19, then let me run it again. It should return me. I think it should return me true, but I think there's some error I think still. So okay. So 1227 is 5. Then it's 12. Let us actually print it. So basically, in any code, you should always print the for debugging purpose and sort of to check the correctness of the code or not. So let's just print this thing just to understand happiness to have any understanding in terms of any wrong bug in the code that we are having. So um, okay. So basically, let me add this thing with our outside the condition here. Okay. So now I'll start at
loop index 0, current diff is equal to 1. Between 1 and 2, the current diff is 1. Previous difference is equal to minus 1 now. Loop index is, so that is fine. I go to the next index, which is 1. Current diff is 5 because 2 and 7 is 5. And previous diff is 1. Now I go to the next portion, which is, okay, it's written to sort of, there was some error like this because it's returning true only. So I think probably the code file wasn't saved. I guess that's why there was no error in the code. I think the file path wasn't saved actually. So if I run it again once, it returns me true now. And let me try for another example. It's a 21. It should again return me 2. Now let's say have it 2. It should return me false because it's not strictly increasing. So as expected, it's false. If I now do 1 2 is 1 difference, 2 7 is 5, 7 1 is 6, it should return me true. Oh, it's not saved. You can see the saved icon is not there, so that's why it's giving me the previous result. So now it's saved now. Let me run it again. It returns me true. So I hope this. So there is some things in VS Code. I think if you are using, you need to be careful about. I think you need to save to run these things, and also sometimes it's not becomes you are not able to observe these things. But I think overall the problem you are able to get what to do and how to solve it. And if you have any questions, I think we can discuss it right now. And any doubts or anything. Yeah. Any doubts, sort of? If you have, please share.
Previous difference minus 1, sir. Can
Sorry,
you
right.
explain that?
Could you
Previous difference minus 1.
right,
Initially,
right. So which line number you are saying? This one, 24?
the screen is not visible, sir.
Okay, just one. Just one. I'm sharing my resharing my screen. Okay, so line number 24 you're saying, which is the LI
20, sir.
previous.
Line number 20.
Right, okay. So what I'm doing here is I'm actually creating two variables, current diff and previous diff. So I'm just writing the comments here. So this is basically to store the previous um, difference between L of um, L of I minus 1 and L of I minus 2, because I have to do consecutive differences checking. So that's why it's I of minus 1 and I minus 2. And this is to store the current difference between L of I and L of I minus 1. So this difference has to be greater than this difference. And this is absolute difference. That means either I can take L of I minus L of I minus 1, or I can take the other way around. If it's a negative thing, I just turn it into a positive thing. The difference, if it's negative, I just take the absolute value. And I initialize with minus 1 because strictly I have to have current difference greater than previous difference, and 0 is always greater than minus 1. So when I do this, if my so in that sense, current diff uh, for I equal to 0, I equal to 1, it becomes L of 1 minus L of 0. Whatever value I get is a positive value here, and it should be greater than my previous difference. In the initial case, it's always minus 1, so you can always it always holds true. And so it enters into this if loop, if condition, and then I just what I do is like I just assign previous difference to the current difference now, because I have to go to the next loop. Correct. So that's the overall idea. Correct. I hope that.
Sir, in absolute difference function, line number 10, sir, if the difference is less than 0, the absolute means we have to take positive value, sir. It should return
Right.
positive. But here you are
Right.
returning minus.
Oh, so basically this is because if n is less than 0, that means if I have n is equal to minus 5, uh, then minus n should be minus of minus 5, which is 5. So that's why it's minus n here, because n itself has a negative sign, right? So minus n would turn it into a positive sign. That's why it's a minus n here in the line number 11, 10, 11. So again, just to, I hope that answers.
Yes, sir.
So just to confirm once more, let's say I take minus 10, let's say. It should return me 10 only. So as you can see, it's 10. So that's how you define it. And yeah, so any other questions from anyone? Okay. We'll go to the next question then. Okay. Um, so again, let's see this thing. Take this example and let's see what happens here. Returns me false. Why? Because it's 2, 4, 5, and then it's 5 again. So 2 minus of minus 3 is 5. So it's false as per what they have also done here. So okay, I think they have different examples like this, but we have already covered enough examples here. We'll go to second question. We will discuss that. So let's take a few. If you have any questions in the meantime, we can discuss like 2 minutes break sort of, and then go to the next question. I'll adjust my mic a bit so that I think you probably won't hear the background noise. Yeah. I'll just be back. Yeah, so we'll go to the next question, which is so write a function ordinal that takes as input a list of integer L. So that means it's the same problem, almost the same problem. It takes a list of integer L. And return true if the absolute difference between each adjacent pair of elements alternates between increasing strictly and decreasing strictly. Okay, so this is a slight variation of the last problem. We are again considering absolute difference between each adjacent pair, but only it should now alternate between strictly increasing and strictly decreasing. So 151, let's say, 1 5 is basically after difference is 4, and 5 1 is again 4. Obviously, it's not either strictly increasing or strictly decreasing, so it's false. 1528, so 1 5 is 4, 5 2 is 3. Obviously, first portion is strictly increasing, second portion is strictly decreasing, and then 2 8 is 6, and 8 3 is again 5. So this thing obviously is a true condition. So let's write this question, write this sort of example. So I would have a new function base accordion, and again that takes L as a thing. So I'll just copy the first function itself, and we'll make changes in the function in this function accordion. So this is my original function from expanding, and what I have to do is like at each position I have to check if my if it's strictly increasing or strictly decreasing or not. So it's strictly increasing, and then it's strictly decreasing, and then it's again strictly increasing, and then it's strictly decreasing. So it's alternates. So if I have to see this alternate, I have to do something. Uh, right. Let's go back to the examples one. Uh, so 1 5 is 4, 5 2 is 3. So current difference, previous difference is 4, and current difference is 3, and then my previous difference is 3 again, and the current difference is 6, and then the previous difference is 6, and the current difference is 5. Okay. So we need to make sure that is the differences are alternative sort of. So let me think of how to do this. Okay. Right. We will add some extra variables, which is increasing is one thing, okay, is decreasing is another thing. These are Boolean variables. So what I would do, I would calculate the same thing as the last problem. I would do is current difference greater than previous difference. So that means, so what I have to do is it should start with increasing strictly and then decreasing strictly. So for that, if my current difference is greater than previous difference, what I do is that I just do previous difference equal to current diff, and I do loop index plus 1. Additionally, what I do that is increasing is equal to true now, because obviously it is increasing over time. But I also have to check whether it was previously decreasing or not. So I would add a AND condition. It says whether it's decreasing. So basically, 1 and 5, the 1 to 5, basically current difference is 4, previous difference is -1. Obviously, is the first two elements only, and is decreasing is also set to true, is increasing is also set to true. Um, and so this if condition holds, I then do previous difference equal to current diff, and I'll just increment the loop. And then what I would do is I would say that if my uh, so this thing currently is sort of is an increasing thing, so I would also do is increasing equal to 2. Is decreasing was 2, and now I am doing is increasing equal to 2, but currently is decreasing now is false. This is currently false, and I'm setting it to false. And for the next loop, when I go, I will have another else condition which is this thing. Um, that's the alternate thing which I'm adding. Um, if either of these conditions doesn't hold, I'll just say it's a false condition. So basically, what I'm doing here is I'm starting with is increasing, is decreasing, both set to true. If my current difference is greater than previous difference, and it was previously decreasing strictly, and now it's increasing sort of um, sort of uh, increasing strictly now. So what I'm doing is like if it's increasing strictly, that means this is thing is holding. I'm saying is increasing setting to true, and but since now is increasing is true, is decreasing will be set to false now. And then this thing is a case where is decreasing is false, but previously it was increasing. So I said is increasing to false now, and is decreasing. This current setting is to true. So let me run some examples and see what happens between according, let's say, the example from this thing, which is 1583. So this is true because as per what they have done. Let me also try out a different example first. Then we'll go into questions that if you have any. This should return me true also. It can say false. There's some error in the code, I think. So minus 2 comma 1 gives me 3 as absolute value. 1 comma 4 is 1 comma 5 is actually 4. So oh, it's 3 and 4. And I think this should be false. So please confirm the chat if you think this should be false. This because minus 2 comma 1 the difference is 3 and 1 comma 5 the difference is 4. So it's not strictly increasing and then strictly decreasing. If you are able to understand the problem, please type in chat if you or maybe uh, confirm if this is the wrong answer, I think, which they have given in the PDF file. This should be false. Okay. Just wait. If you have any questions, please feel free to ask now. Feel free to speak up and ask if you have any questions. Okay. Uh, so in assignment, they're asking to writing test case. So there is some question in the chat. Um, could you please share more in broad details? I think someone had asked a question. Now, how to write test cases. So test cases are basically things that I'm sharing in the while writing the code in the current on the screen. If you see, for example, these are like my test cases. I can add some more test cases like this, um, like random test cases that you can try to see. If I do for all of them, it's giving me false right now. The 1 3 is 2, 2 7 is 4, and all. So you can write similarly test cases like this and try to see if your code works or not. So I guess that was your answer. Machine sort of. Do we need to write code in the final exam? Yes, you need to write code in the final exam. Yeah. Because it's a Python course, so and some small level of code understanding is required. So you need to write that. Uh, any other questions? Please feel free to ask if you have any questions. Um, so another question is, can we get program list for exam? So by program list, I didn't actually understand what do you mean by program list. Could you please clarify? Um, System provided. Yeah, see, any coding system will be provided in the exam hall, so that won't be an issue. We will be able to sort of utilize that coding platform. So there is no, if you, so Abhay has asked the question, so what can we get program list for exam? So there is no specific program list. If you mean by program list something like list of programs or Python programs to access, keep practicing for exercises, I would highly suggest practice on HackerRank. HackerRank has a Python practice section itself. I think I have shared this last time, so let me share that once more. So yeah, please try to, if you're able to see my screen, please try to solve these problems. I think these problems are very important to sort of get an idea, hands-on idea of how to, so with the way of solving. There would be there would be similar terminal as such in the exam as like in your assignment. So, but what exact terminal, what system you have to confirm with the exam coordinator or the course coordinator maybe. But there will be similar terminal as in assignment submissions that you're going to. So please, again as I mentioned, please please sort of practice on Hacker because this gives you some extra additional exercises to practice on apart from the lecture series. So for example, lecture 3 of week 3 has a specific section called digging out of a loop. So in the code, if you see, what I did was something like breaking out of a loop itself because I was using something like this one. Okay, we shall must be once. So I was using something like if my condition fails at any one of the steps, I go to the else condition and I just simply do return false. So it basically breaks the loop for loop. So even I don't have to traverse through the entire loop over the entire list L. Instead, I can break free of the loop very early on. So that's why sort of what breaking out of a loop means. So lecture 3 covers this concept. I think as per the video that we have gone through. And yeah, so we'll do some more examples. I think sometime back, some people have discussed about binary search on to discuss that. So lecture 4 actually discusses binary search. So we'll probably discuss that a bit in a moment today. And so let's first discuss binary search, I think. And then I think we can continue on this problem sheet and stuff. So, so before that, if you have any questions, feel free to ask any questions if you have. Okay. So basically, so for binary search problem, we mostly looking at arrays sort of. So before we directly head on jump to binary search problem, I would highly suggest you to try out one problem by hand during the class session itself. So that gives you some aspects of how to deal with arrays, because array is something that we already have gone through and the lectures have also gone through. So let me search for some array problems that you should look into. Uh, there are no specific array problems I can have. Basic data types I can have. Okay, so maybe let's try list only. So this gives you some idea of how to deal with lists. So I hope you're able to see my screen. Um, so that was resharing on screen. I think my screen is not visible. Okay. So you're able to see my screen. So the problem is given list, we perform the following: insert integer e at position I, we print the list, remove e, append e, sort, pop, reverse. These are the available sort of things that you can do with the list. And we have to sort of do this. So if it's so initialize a list and then read the value of n, followed by n lines of command, where each command will be of 7 types listed above. So 7 types are insert, print, remove, append, sort, so on. You should iterate through each command in order and perform the corresponding operation. So yeah, if anyone is speaking, hello. If anyone has a question, please feel free to ask. Um, okay. Going back, so n equal to 4. The sort of first instruction is append 1, then append 2, then insert 3 1, and then print. So append 1 actually does 1 2 array, append 2 does 2 2 array, insert 3 1 does insert 3 at index 1, and then print basically does is printing the array. So this is my output. So this is a small exercise. I'd say please try out right now. Uh, please open up a suitable Python editor at your end, and please share the solution in the chat and the code sort of. And if you have a code, what you did in the code, please share in the chat. So let's take a 10-minute sort of exercise quiz of this thing, and write this thing up. So I highly suggest everyone's participation, like because this list and all, I think we have already covered. So if you have any confusion, it's best to sort of ask questions like that, because we will be heading to binary search and other problems. So that would be useful at that time also. So please solve this problem and share in chat any solution that you may have. Uh, yeah, so please solve the problem. In the meantime, please share any of the solution you have in the chat. If you have any Studio, VS Code Studio, or any other Python editor, please share that in chat. So do we need to write test cases? Yeah, I think in the final exam you need to write test cases along with the functions. Yes. Yeah, I think one person had already shared code. Please feel free to share. Others also feel free to share. We'll discuss the code in some time. Once everyone has all the code shared, we'll discuss the. Also, as part of this, we'll also discuss how to write efficient code. I mean that efficiency was also part of the lecture. This lecture 4, I think, in week 3. So we'll discuss that also. So please share your others. Please share your code. We will comment on this. Okay, I think others probably if you have code, please share. So I think we need to continue on. So Sachin had shared a code. So so I'm just going through the code. I'll just share any sort of high level questions if I have, and probably give you an overview of how you can probably improve your code also. So right, so you have a basically a nice equals condition anyways. So you can also do switch cases also in Python as an alternative. So okay, so overall there is no sort of the code is correct and it should work. So thanks for sharing the code final update. So going back now, so since lists, so regarding efficiency and all, so in the current code, we have already sort of used the list functions like pop and reverse, but you can also try out your own custom implementations of pop and reverse instead of the actual function definitions also. And there you can do some efficiency, how to write the code for the words, how to write. So by efficiency, what I mean is like, for example, in if you want to write a for loop, let's say, and let's say you have a nested for loop, let's say, of two variables, how can you simplify the code even further? So those kind of things fall under efficient code writing. So we'll discuss in more those things later, I think, upcoming weeks also. So we'll go back to the binary search problem. I'll just sort of go briefly what binary search is and then the binary search in Python problem. And so, so I'll just briefly discuss binary search problem first, and then I'll discuss the Python in Python sort of how to do it. So let me okay. So let me share my screen. I hope you're able to sorry, um, you're able to um, my screen is okay. So we'll discuss the binary search problem. Basically, it means we want to search an array sort of. So what are the possible ways to do that? One way is to do it as a linear search. So basically, that means you go linearly through an array to search for the elements in the array. And if you find the array, you stop the loop sort of. And or if you don't find the array, you go on. So basically, you have a for loop. And so this thing is written in C++, but anyways, I'll just give you a brief highlight of what the binary search problem is, and then we'll go to the actual Python code. So the word space complexity is order of n basically because it's a sequentially and looking at each element and seeing whether the element is the element I'm searching for. So it actually loops through the entire list of array, list of elements. So it's order of n. But if it's sorted, let's say, so you can stop early to find the element greater than x. Let's say if my array is already sorted, then let's say 1, 2, 3, 4, 5 up till 10, and I want to find the element 5, let's say. So I can just loop it till 6, let's say, because after 6 or equal to 6 or after 6, I won't be able to find 5 anyways. So 5 should always be before 6. So if my array is sorted, then I simply don't want to loop through the entire thing. But again, the versus complexity here is also order of n because in this case, an example is if x is larger than any element in it. So let's say 1 to 5 is my array A, and the X is the element that I want to search for is equal to 7. So in that case, I have to loop through the entire array, and so that's my order of and worst case complexity. So can we do better on sorted arrays? One option is to look in the middle of the array, compare the midpoint element with X. If it's found greater, if it's actually found, then it's great. If it's found at the middle place, middle of the array, if X is smaller than the middle of the element, I usually look into the lower half, or if X is bigger, I look into the upper half. And this exactly is the binary search algorithm itself. So you go with the assumption that your array is sorted. You start at the midpoint element. That means if I have 10 elements in the array, I look at the fifth element. I compare it with the X I want to search for, and and sort of if my X is actually greater than the midpoint element, I look at to the right side of the array, or I go to the left side, and I usually do this recursively over time. So once I go to either parts of the array, I again do the same thing. I again compare the middle part of that particular subpart array, and again search for either of these two things, and so on. So it's a binary search problem, because why better? Because we are throwing away half of the array each time, and with linear search we are throwing out just one element. And if an array has a length n, we can halve it in log n times. So that's the sort of essence of binary search. And I'm not going to the exact any other details here, but just an example here. Binary search A, which is sorted 2, 3, 5, 9, 11, 13, 17. I want to look for x equal to 4. So I look at the middle element 9. I check if 4 is greater than 9 or 4 is less than 9. 4 is obviously less than 9. So I reject all the elements on the right hand side. I only look at the left hand side of the array 2, 3, 5. I again go to the middle, which is 3. And so 3 is less than 4. So I ignore this left hand side elements. I only go to the right hand side, which is 5. And I compare 5, which is again greater than 4. And I don't have any other array to explore. So I just say that code is not found in it. So that's my sort of algorithm as such. If you have any questions here, feel free to ask. I will pause here for a few more minutes, sort of, if there are any questions. Yeah. Okay. Any questions? Feel free to ask if you have any questions in the binary search algorithm. Okay. So we'll probably write the code now for binary search in our base code. So let us do that. And if you have any questions in the meantime, feel free to ask. So let me share my screen. So let me erase this part and write binary search code in Python. So the binary search array X. Basically, this should be so array is no element that I have. X is the element I want to search for. I do a low which is equal to 0, which is the lower index, and I do a high index which is equal to len of add minus 1. And so if low is equal to less than equal to high, which is obviously always true because that's what I'm initializing to. So I define low is equal to high minus low by 2. This basically is another way to say I want to avoid overflow. That's why in case of large inputs. So basically it's mid is equal to low plus high by 2 only. If array mid is equal to x, I just return that. If array mid is less than x, then I go to if my x element is greater than the middle element, I go to the right hand portion of the array. So I just do low equal to mid plus 1. That means I go to the right hand sort of x is in the right half sort of. That's my thing as array. And otherwise, if it's less than the middle element, I just go to the left hand side of the axis form. Okay, where I have the left hand. Okay, so now I would do if any of this case happens, I would return mid. Else, I would do I would return let's say minus 1 if x is not found. So let us run this for few examples. So I'm writing test cases 1, 2, 5, 6, 8 should return me. The middle position element is 3. So it should return me the index at which I'm finding the element. 6 it's as index 2 is my example. Um, 4 if I want to say search for 6, search for 7, search for 5. This is array input. I can have similarly a lot of other test cases like this. So let's try this all these test cases out and let's see. It should return me 3 print of binary search 1 6, print of binary search 1 2 6 7 8, and where 7 is the element I want to find should be at index 4. Similarly, 5 is not there in the array, it should return me minus 1. 1 is there in the array, it should be returning me index 1. I think instead of writing this as I should give it as mid plus 1 because it's 0 index, so that's right. Let's run these things. So first element gives me 3 4 minus 1 1 5 minus 1. It's 3 4 minus 1 1 5 minus 1. So basically the same thing as per the test case results that we wanted. And so my binary search array should pass all the test cases in the example. So this is my sort of code for binary search. If you have any questions, feel free to ask. Let me know. If you have any questions, feel free to ask. I'm sharing a snippet in the chat so that if you have any questions here. So let me know if you have any questions in the code, any understanding issues, anything. Yeah, any questions, please feel free to ask. So Abhay has a question. All search we have to study. Yes, I think mostly binary search and sequential search, linear search we have to study. Yeah, for sorting algo, you have to study the important ones, which is bubble sort, insertion sort, and maybe selection sort you can think of. You can also have a deep two as a optional thing. Merge sort, bubble sort, and sort of insertion sort. Three sorts algorithms are the important ones. Um, um, and selection sort is something that you can also do by the side. Quick sort is also one of them. Quick sort, merge sort, and quick sort, merge sort, and bubble sort and insertion sort. All four of them, plus selection sort. Okay. Anyone has any questions in the binary search algorithm? Okay. Mhm. I will probably then go ahead with continuing on the week 4 quizzes, sort of. So, so week 4, I think I'm just going over the syllabus once, what you have to cover and all. So week 4 has merge sort analysis, quick sort analysis. So only two sorting algorithms are there, merge sort and quick sort. And you probably would do some analysis. Like the two important algorithms are merge sort and quick sort, so you can expect most questions from these two only. But also, it's best also to do a study of other sorting algorithms, because in week 3 you are already going through insertion sort and selection sort. So you should also have some ideas about those. So we can probably discuss. We discussed binary search and all. We can probably discuss about um, um, the case of um, uh, let's say insertion sort as one of the examples, and then we will head towards merge sort in the next class also. So let me open up the slides for insertion sorts just to give an idea what insertion sort is, and then we'll sort of work on this thing, go towards working on like in Python, like how to write the code. So this basic understanding of insertion sort. So we try to open up this thing. Just let me know if you're able to see my screen. Okay. So we'll. I hope you're able to see the lecture slides. What is insertion sort? It's a simple and efficient comparison sort itself. Basically, in this algorithm, each iteration we remove an element from the input and we insert it in the correct position in the list that is to be sorted. So that's the basic sort of idea here that we want to sort of do an insertion sort. So we'll go as a diagrammatic representation of how to do this, because that should give you some idea about how to go about like um, the how, how to go about implementing actually in the long run. So um, let, let us go through the one example first. So again, like first, let's discuss like the characteristic of insertion sort. Basically, you want to also remember which sort is being asked in the exam. So that should be important for getting an understanding of sort of how to like what sorting, because there are multiple sorting algorithms. One is quick sort, one is merge sort, one is insertion sort, selection sort. So which algorithm has which characteristics is important to know that. So that should give you some idea as to why some of the algorithms are beneficial while some of the other algorithms are not beneficial. So insertion sort is a simple implementation itself, because it doesn't have too much complexity, and it's very efficient for small data, and something called adaptive, because if the input list is presented may not be completely, then an insertion sort takes around order of n plus b, that is the number of inversions. Not going to the exact details much, because there is some theoretical aspects also, which is not needed that much in this course. Um, Key points that you need to remember, which might be used asked during exams, is that insertion sort is stable. That means it maintains relative order of the input data. So basically, let's say I have the input array as, let's say, 57 uh, 5719 as the input element. So when I do sorting, it would be 1579. So if you see, 5719 was the original input. Now it becomes 1579. So 7 and 9, the position is already sort of the relative order in the input data, whatever it was, is now already there in the final ordering also. So that stability is maintained. It's also in place. That means it requires only a constant amount of order of one additional memory space. You don't need to have a separate array to do the operations around, and you can do it online. So you can, what is online? Basically, it means that as and when the array elements come in, you can sort. So it's online. So just go to the algorithm. If it is a first element, it is already sorted. That means it returns one only. As step two, you pick the next element. As step three, you compare with all the elements in the sorted sublist. As step four, you shift all the elements in the sorted sublist that is greater than the value to be sorted. And at step five, you insert that particular value. And step six is basically a repeat to the entire process until the entire list is sorted. So, giving you an example here, so you have a sorted partial list. This is the sublist that you're saying. It is less than equal to x. Whatever elements fall after that is greater than x, and these are all unsorted elements. And this becomes as and when you repeat this algorithm, the entire list becomes sorted after some time. So, give an example here. Given an array 6, 8, 1, 4, 5, 3, 7, 2, the goal is to put them in ascending or increasing sorting order. So you start with 6, consider index 0, you then go to index 0 to 1, 6, 8, um, and then you consider indices 0 to 2. The insertion takes place places 1 in front of 6 and 8. So when you have 1, it picks the right position and places it before 6 and 8. You then go to 4, it takes the right position, places it in 1, 4, 6, 8, and so on like this. And finally, we have the array as sorted. So till now, if you have any questions, feel free to ask here. Yeah, if you have any questions, feel free to ask in the algorithm example we focused. Okay. So we'll do some analysis. I think this was done in the lecture also. So worst case analysis basically means that in the worst case, when for every I, the inner loop has to move over all the elements a1 to a minus 1, which happens when ai is equal to the value that you want to find out is smaller than all of them. And so it takes order of I minus 1 as a thing. And in a way, it's actually, it come out to be order of n square as the sort of time complexity. So if you just keep on adding order of 1, order of 2, and so on up till n, so it would be order of n square approximately. And so this is a very high costly operation. And so insertion sort in worst class complexity would give you n square as the order as a complexity. These are the type of questions I think in the exams you might be asked in terms of complexity wise. What is the worst case complexity of insertion sort? What is the worst case complexity of selection sort? In terms of search, binary search, what is the worst case complexity? In terms of quick sort, what is the average case complexity and the worst case complexity? So something like this would be asked. So it's better you understand the algorithms a lot better so that it helps you to answer this question. So, um, so I'm sharing some questions to practice so that you probably can answer them. So I'm sharing my screen here. So what is the worst case complexity of insertion sort where the position of data to be inserted is calculated using binary search? What do you think is the worst case complexity in this case? Anyone has an answer?
Sorry, n into n login, n into login.
Sorry, there was a echo in the background. Could you please write in chat? Could you please write in chat whatever question you have? What do you think would be the worst case time complexity of insertion sort in the position of the data to be inserted is calculated using binary search? Okay.
Sir, is it n square?
Okay, let us see if it's n square or not. It's obviously not n square, but let's see. It's n square. So why is it? So applying binary search to calculate the position of the data to be inserted doesn't reduce the time complexity. So in original case, it's n square anyways, because when you have the worst case, which we already discussed in the analysis, is n square. But let's say you calculate the position and you shift the data from the position calculated in step one to one step to create a gap, and you do binary search to use the time complexity for the position searching. But anyways, you still have to do you still get the same complexity element wise of order of I minus one. So that's why you have overall complexity equal to one square. So let us go to the next question. Given an array 12, 13, 35, 78, 56, and P is 78, how many iterations are done until the element is found using binary search? Um, what do you think would be the answer? So it should be two because I first consider the middle element and see whether it's 78 or not. It's not. It's greater than 35, so I go to the right hand side. I even go to the middle element 78. It's the one that I'm searching for. So all I do two iterations only. So this is the current answer. So now going to the next question. Select the best description to explain what a binary search algorithm is. First, put the elements in order. Check each item in turn. Elements do not need to be in order. Compare the middle value. Split the list in order and repeat. Elements do not need to be in order. Check each term in each turn. Put the elements in order. Compare with the middle value. Split the list in order and repeat. So, what do you think is the right option here? Anyone can comment in the chat. Yeah, the fourth option, because this is what is binary search is. So again, I think we probably don't need to discuss that. So now, going to the question 4, what is the best case time complexity of binary search to find an element? Is it log of n? Is it order of n? Is it n squared or 1? What do you think is the best case time complexity of binary search? Anyone has any option to choose from? Please type in the chat. So option 4. Okay. So option 4 basically is because, let's say, you find the element right at the middle itself that you want to search for, right? Because this is what the expression is. The element is right at the middle, and you just by chance get the element in the first uh, iteration itself. So it takes only one comparison in that setting. So it's always performed. Going to the next question now. Binary search is to be performed on the list 357 times 23. How many comparisons you have to do to find the number? 7. Again, it's a very simple question. It's something similar to the previous set of questions you have already seen. So what do you think would be the number of comparisons here? Okay. Srimugaran says 2 to 3. Agar says 2 to 3. Mm. So again, okay, see, you answered 2 to 3, but so any before we go to the explanation, any logic why you thought it should be 2 to 3? Can anyone answer in the chat? Can anyone mention in the chat why you think it should be 2 to 3? So the answer is wrong because I'm finding 7 right at the middle. So 7 is at when I do binary search, I first find the middle element. In my case, the middle element is 7 itself. So I just need to compare uh, that with that itself. So it's 0 to 1 in this case. That's right. First iteration left equal to 0, pointing to 3. Basically, that means is pointing to 3. And the point to 0. And since RMA 7 is found at the first iteration itself, so option is correct. So that's the answer. So I'm going to the next question now. What are the mid values corresponding of the corresponding array items produced in the first and second iterations for an array 23, 45, 67, 89, so on. And the key that I want to find is 90. So what is the mid values produced in the first and second iteration when I want to search for 90 in the corresponding array? What do you think would be the answer here? Yeah, any sort of response? What do you think would be the answer? Okay, so the answer would be 6790 because I'm searching the mid element, which is 67. 90 is greater than 67, so I go to the right hand side and again do at 90. So that's the answer. So okay, so I think that's it. We probably would end the call now. I think if you have any other questions, feel free to ask now. So again, we'll take an extra class next Saturday because last week Sunday class we actually had to cancel. So we'll take so this week's class is basically a replacement for last week's Sunday's class, and whatever class lecture we will be covering this week is going to be held up at Saturday. So week 3 was supposed to be held at last week Sunday, but it got postponed to today. So we discussed mostly week 3 discussions in this lecture. Week 3, some portions, and mostly week 4 would be covered in next Saturday, same time, same meeting link, 3 to 5, same meeting link and same time on Saturday. And again on Sunday next week, we would have week 5 lecture and with the everything related to week 5 on Sunday as usual. And Sunday's class would be as usual. Saturday is an extra class which would be covering week 4 of the lecture series. So if you have any questions, feel free to let me know. And also feel free to post anything. I think I've already invited you to some Slack channels and all. And some of the lectures are also on YouTube. If you have any questions, you can also post it there, whatever works for you. Or you can also post in the Slack group also. And we'll again meet next week, Saturday, same time, 3 to 5, and on the same Teams meeting. So with that, I think we should probably end this call today. We'll probably discuss about the sorting algorithms, quick sort, merge sort next week, and some of the analysis as well as some of the problem quizzes, solving the quizzes and all next week. So with that, I end this call here. Thanks again for joining. I hope this was a productive session for you all, um, and hope to see you again next week. Thanks again.